Okay, welcome student to section 11.4, the limit comparison test. In this question, we have a similar question to the previous one. It's arctan, which is tan inverse over n 1.2. And if you look at the previous one, it was ln n over n, so it's kind of similar. So I will try first of all to use the same idea as we did before. The idea is Pn, I will write it n 1.2, and here I will write 1. Why I did this? Because by looking at this, it's a simpler function and it's well known whether it converges or diverges. We know that 1 over n 1.2 converges. And why this is converges? By the p-test with p equal 1.2 greater than 1. Which is good. It's converges. Now let's find the limit. The limit will help me to get to the final answer. So I have an over Pn equal limit n goes to infinity. An is arctan n over n 1.2. Bn is 1 over n 1.2. This is a stack of 4, so you just have to write it down. It will be arctan n 1.2, and then the top we get n 1.2. We do cancellation, and finally we get L is equal to the limit n goes to infinity arctan n, and if you substitute infinity you get arctan infinity, which is same as tan inverse of infinity. Now, do you remember how much tan inverse of infinity? We said it at the beginning of the semester, and we also said if we forget how much it is, go to your calculator, write tan inverse, and instead of writing infinity, write a very large number, 9999999, as much as you can in your calculator, and the calculator will give you an approximate, and the answer is pi over 2. If you don't know or you forget, now here how we find it. Of course, this is between 0 and infinity. So by the limit comparison test, we conclude that my series in the question and the series Pn, they have the same behavior. So both converge. Okay, next. This example. Okay. This example, let me do the same as we just did now. Here for Pn, I always like Pn to be something over something. So how about we ignore the sign? Just let me try use 1 over n. Of course, 1 over n, I know it is divergence. By the b-test with p equal to 1. Now, how much L? L is the limit as n goes to infinity an over Pn equal to limit n goes to infinity. An is sine 1 over n. Bn is 1 over n. In this case here, there are many ways to solve this question. Okay, many ways to find this limit. You can use L'Hopital if you want. Because now if we do direct substitution, how much we get? I think we get sine 0 over 0, which is 0 over 0. So let's use L'Hopital just to be on the safe side. Derivative of sine is cosine. Derivative of the 1 over n is this one. Derivative of 1 over n here is this one. It's clear there is cancellation, which is this and this. So we finally end up with this one. Sorry. Cosine 1 over n. If you substitute infinity, you get cosine 0, which is 1. So L is between 0 and infinity, and hence by the limit comparison test, both series they have the same behavior, which means both diverges. Okay. Final question is this one. I think we already did similar question, so I will just maybe give you the idea up here which one to use as Pn. This is a very good question because here we have to make a trial. So trial 1. Choose Pn equal 1 over n cube. Okay. I want you to practice by yourself. Find for me the L and tell me what can you conclude. Trial number 2. I want you to use Bn 1 over n squared. Find for me the L and tell me what can you conclude. Okay, I want you to do this by yourself. Check which one will give you the answer and why trial number 1 will not help you, but trial number 2 could help you. So I will wait for your answers in the comments in the master file. I want someone to explain it very well. If you can make a video, that will be very helpful. Just mention that this is section 11.4, example 9, or you can just say this is exercise, I think in the book. Let me just quickly check which exercise in the book. It is exercise 40, part B. Thank you.